All right, guys, we're going to get into a very quick test review for your tests over nuclear reactions. I'm just going to point out the highlights for you. All right, so first thing we want to make sure we understand is fission versus fusion. Right here in front of you, you have an equation. And so key things I want to point out is if you have this equation and you've got two things, one, two, I've got a large nucleus and a neutron. This is always going to be fission. Fission takes it up and it breaks it into smaller pieces. So fission has to have a neutron to start it. Another key point I want to point out is the mass on each side will be equal. If I take the mass of the left, I've got 239 plus 1 neutron. That will give you 240. If you look at the other side, you've got 144, 94, which is 238, but you've got two neutrons. Don't just add one, you've got two neutrons, so plus 2. This gives me 240. So the masses for both sides will be the same. Key things about fission: 1, starts with a neutron. 2, it happens in power plants, and it produces a lot of energy, but not as much as fusion. Okay. After that, that is all you really need to know for fission. Fusion, on the other hand, fusion is going to combine. So if I combine and I am taking two small things, hydrogen is small, and I'm making them bigger. Yes, this says helium, but if I start with hydrogen and nitrogen, I'm going to make it bigger into helium, and I have a neutron. No matter what, your mass will always be the same. Okay, this is fusion. Fusion does not happen on Earth, and it's not because it's unable to happen anywhere besides the sun and the stars. It's just too hard to contain. It's too hot. It's hard to contain it. That's why it doesn't happen here. All right. Looking at the mass here, I've got 2 plus 3. This is 5. Over here, 4 plus a neutron has a mass of 1. This is also 5. So they would be equal with one another. Okay. Pros and cons of nuclear energy. Some of the pros we found that it is long term, it's more inexpensive, it's efficient, it's not, it can run out, that's a con. Some of the other, it produces a lot of energy. Nuclear reactors actually don't take up a lot of space per se. Some of the cons would be it's expensive. You've got the risk of nuclear meltdown. You've got to store the waste somewhere. Another pro that I just thought of is that it doesn't pollute. There's no pollution. You're going to lower your carbon footprint. So make sure you understand that. All right. And then we've got 3 types of decay. Okay. So you've got alpha decay, and that's going to be released as a helium particle. Make sure when you're looking at it that if it's alpha, it's going to start with one thing, and then we're going to break it down into He4, 2, and then mass would be the same. So key points here, say I started with carbon 12, 6, C, and make it undergo alpha decay. I am going to subtract 4 from the mass. That would give me 8. Subtract 2 from the atomic number. That gives me 4. And if you look at a periodic table to determine what that element is, that element would in fact be beryllium. Okay, the mass on both sides should both be the same. Alpha, if I draw this scale, alpha is going to be the heaviest. All right, it will be stopped by paper. All right, it has a positive charge to it. All right, beta, on the other hand, beta will be stopped by metal. All right, beta looks like an electron. So you go 0, -1 in E. All right, so if I started with the same carbon, 12, 6, and I make it undergo beta, 0, negative 1e. I subtract across, the mass does not change. 6 minus negative 1 would give you 7, and I would be left with nitrogen. Okay, beta is a negative particle. And then your last one, which is your most powerful, okay, would be gamma. Gamma is pure energy, looks like this. So if this carbon undergoes gamma decay, nothing is going to change except the release of the energy. All right, those are the 3 types of decay. Now, if we look at this diagram right here, all right, point this out to you. This looks kind of weird, but if you look at the diagram, and I'm asking you which one is where each kind of decay is going. You've got alpha, which is positive, beta, which is an electron, so it's negative, and then gamma is neutral. All right, if I consider this to look like a magnet, where I'm shooting it out, it's going through this plate, and it is attracted to the negative side. Remember, opposites attract. So this is the negative side. This would be a positive. This would be alpha. This one comes through the middle, and it's not attracted to either side. That would be gamma. And then down here, this is going to be attracted to the positive side. Opposites attract. That's going to be a negative, which is beta. Okay. And then the last thing we're going to look at is half-life. So in order to do half-life questions, you need to make your chart. I know you don't like making the chart, but you got to make the chart. So this one says nitrogen-14 is a radioactive isotope that sometimes is used to sterilize medical equipment and medical waste. And that should say nitrogen. Nitrogen-14 has a half-life of 10 years. How long will it take before it's less than 5%? So I'm going to make my chart. I'm going to put percent, and I'm going to put time. All right, I'm going to start with 100%, and I'm going to break this down all the way until it's under 5%. So I've got 50, 25, 12.5, 6.25. I'm not stopping yet because I'm not under 5%. And then I've got 3.125. This is what my answer should be. Okay, so I remember my time always starts with 0. So this is going to be 0 years. I'm going to add 10 every time. 10, 20, 30, 40, and my answer should be 50. If you don't start your time at 0 time, you will not get them correct. All right, there's lots of study stuff. Make sure that you study pros and cons. That's going to be on there. All of this information is on there.